Welcome to another video. To solve the equation on the board, we can analyze the behavior of the functions on both sides of the equation and use numerical or a specialized mathematical function. That is a Lambert W function. So to use Lambert W function to solve for the value of x in this equation, the first thing I'll need to do, is because x will be less than 0, so I can say let x equals to negative k. So, noting that k is what? K is greater than 0 because I said x is less than 0. So which means what I'm trying to do in this case is to find the exact form of the root for x, because x is less than 0. So which means from what we have here, we're going to have negative k raised to the power of 2 equals to 3 raised to the power of negative k. Now, square of minus k, that will be k squared, and this will be equals to 3 raised to the power of minus k. So now, I'm going to multiply the exponent on both sides by 1 over 2, Multiply the exponent on both sides by 1/2, so this will be k raised to the power of 2 multiplied by 1 over 2. This will be equals to 3 raised to the power of minus k times 1 over 2, so that this will be k equals to 3 raised to the power of negative k all over 2. Now, let's not forget that because I said we're going to use numerical or a specialized mathematical function, that is a Lambert W function. So what I will do is to write this, exponentiate this. So we're going to have this to be k equals to e raised to the ln 3 raised to the power of negative k over 2. And this is same as k equals to, so that is, this is e raised to the ln 3 raised to the power of minus k over 2. So which means I'm going to bring this down. So this will be e raised to the negative k ln 3 over 2. And this is same as k equals to e raised to the power of, that is 1 over e raised to the power of k ln 3 over 2. ln 3 over 2. All right, so now I'm going to multiply this k, that is, I'm going to multiply through this equation by e raised to the power of k ln 3 over 2. So when I do that, this is going to become, the left hand side will be k times e raised to the power of k ln 3 over 2 equals to, now if I multiply 1 over e raised to the power of k ln 3 over 2 by e raised to the power of k ln 3 over 2, then I'm going to get 1 on the right hand side. So now, because we want to get a function of the form, that is, to get a function, of the form, when we have, let's say we have this, we want to get a function of the form, that is, for us to use the Lambert W function, we know that we need to first write this function, manipulate this to be in this form. Then when we then find the Lambert W function of whatever we get, that is the Lambert W function of the product of infinity, and e raised to the infinity will be equals to infinity. All right, so which means now it means that to be able to get this form of expression on the left hand side, I'm going to multiply this equation by ln 3 over 2 rather. So it means that I'm going to multiplying both sides, multiplying both sides by ln 3 over 2. So which means on the left hand side we're going to have k ln 3 over 2 multiplied by e raised to the power of k ln 3 over 2. And on the right hand side, 1 multiplied by ln 3 over 2. This will be ln 3 over 2. Okay, so which means we now have what looks like this. Okay, we now have what looks like this. Okay, and like I said, it is only when we have this expression, that is when we can now what? We can now look for the Lambert W function of this form of expression, and that will be equals to, so which means in this case we have k ln 3 over 2 multiplied by e raised to the k ln 3 over 2. So I'm going to find the Lambert W function on both sides. So let's find the Lambert W function. So which means this will be the Lambert W function of k ln 3 over 2 multiplied by e raised to the k ln 3 over 2, okay, will be equals to Lambert W function of ln 3 over 2, okay. So in this case, we're going to have this to be k ln 3 over 2, and this will be equals to the Lambert W function of ln 3 over 2. Okay, so now I'm going to multiply. Remember, in this case, okay, I'm going to isolate k. So to isolate k, what I'll do is I'm going to multiply both sides by 2 over ln 3. Okay, by 2 over ln 3. Let me write this here. Now, so like I said, multiplying both sides, okay, of this equation by 2 ln 3, okay, multiplying both sides by 2 ln 3. So which means on the left hand side we're going to have 2 over ln 3 multiplied by k ln 3 over 2, okay, equals to, so I'm going to multiply the right hand side by that as well. So we have 2 over ln 3, then Lambert W function of ln 3 over 2, okay, so that this will cancel this will cancel this, so we'll be left with k equals to, so we're going to have 2 over ln 3 multiplied by Lambert W function of ln 3 over 2. Okay, now let's recall. We know that x is equals to negative k. So which means we're going to have x rather. Okay, x to be equals to negative 2 Lambert W function of ln 3 over 2 all over ln 3. Now, so when I look for the integer solution of the value of x, okay, first of all, I found that ln 3 over 2, okay, is approximately equals to 0.5493, okay, so which means the Lambert W function of 0.5493, okay, that is, this will be equals to 0.3767. So now when I plug in the values, then I got my value of x. X is approximately equals to 0.6860. So this is the value of x that satisfy the equation. I'll see you in the next video. Bye bye.